This is a physics tutorial for OCR Gateway Physics GCSE, and we're looking at P1G wireless signals. In this tutorial we're going to cover wireless communications and long distance communications and interference. We're going to start off looking at wireless communications, and these images here show some examples of uses of wireless communication. TV and radio work by receiving radio waves, so wireless broadcasts, and laptops use Wi-Fi. They also use radio waves to communicate with a router to access the internet. Some advantages of using wireless communication: that you don't need to connect to an external line, for example telephone line. This makes them portable, which is quite a convenient thing, and it means you can access things whilst on the move, for example your mobile phone. A disadvantage is that you need an aerial to pick up the signal. I'm going to talk now about two ways in which wireless signals can be sent over long distances. The first is by using satellites. So a signal is broadcast from a transmitter on the surface of the Earth. It's received by the satellite and then retransmitted back down to Earth again to be received somewhere else. It's important to note that the signal is retransmitted and not reflected or bounced off of the satellite. If the signal were reflected, the incoming and the transmitted signal will both be in the same frequency, so they would interfere with one another. Microwaves are used for satellite communication. This makes use of one of the properties of microwaves, that they don't diffract much, so the signal received at the satellite hasn't spread out too much and so still is strong. Another means of sending wireless signals over long distances is by reflecting them off of the ionosphere. The atmosphere is made up of lots of different layers, and the ionosphere is a layer of charged particles high up in the atmosphere. If you notice, this particular diagram shows the signal, or the path of the signal, as being curved. So as the signal is travelling from the transmitter, it's not following a straight line, it's following a curved line. When waves or radio waves change direction like this, it's due to refraction. So what's actually happening here? Well, the atmosphere is made up of lots of different layers, and the higher up you go, the less dense the atmosphere becomes. Now we know that when any wave travels through mediums of different densities, the wave changes speed and direction. So the radio wave is actually refracting, and that's why we see this curved path. This is actually an example. This case of reflection off of the ionosphere is actually a case of total internal reflection. For exam purposes, you need only know this, that the radio waves are refracted and then reflected off of the ionosphere. A couple of the things that can affect the signal quality of long distance communications. The first one is diffraction. Diffraction, as we know, is where a wave spreads out. Now, because the wave is spreading out, it becomes weaker and weaker. So the further away you go, the more the wave is spread out and the lower the intensity at the receiver. So a note of that down here. Diffraction results in signal loss, and as the signal spreads out, it becomes weaker. Another reason for poor signal quality is that, as we know, the radio wave refracts as it travels through the different layers of the atmosphere. Now this can cause interference because you get some signals travelling in one direction, some signals travelling in another direction, and they begin to interfere with one another. And that is all for P1G.